sides. And guys, just really quickly, touch the bottom of the tea kettle. Do not say out loud if it is hot or cold. At the end, I want you guys to tell me. Here we go, really fast. One finger. One finger. You guys in the back, you're gonna stretch out. Keep going, keep going, keep going. Stretch out if you guys want to touch it. Gotta reach out. Alright guys, do me a favor, just move a little bit back, make the line going this way. And here we go. Everybody's gonna get to touch it. Don't tell anybody if it's cold or hot, okay? At the end, we're gonna find out. Alright guys, come on over here. Just a little bit back. You can stay there or you could go back to your seats. But audience, tell me. Was it hot or cold? Say it all together. Cold. Wait. I thought you guys said that it was very, very hot. You guys can have a seat. Sit down. Just make sure, guys, when we're here, stay behind those cones at all times. So, Suni, do me a favor, move a little bit. Keep going, keep going, keep going, keep going, keep going, keep going, keep going. There we go. Perfect. All right. So, you guys said that this was hot. But, I mean, that this was cold. But you had told me that boiling is hot. So, let me ask you one thing. Do you think that liquid that I had was water? What do you guys think? Someone tell me yes or no, why and why? Let's see. How about right here? What do you think? No. And why not? Why was it not water? Because it was cold, right? When we boil water, it is very, very hot. Water boils at 212 degrees Fahrenheit. Now guys, let's make sure that this did boil. If it boiled, there should be nothing left because it was all a gas and it left. So guys, is there anything left? No, there's nothing left over. All of that liquid did indeed boil and change into a gas. And it wasn't water. What we had in there was something known as liquid nitrogen. Liquid nitrogen boils at a temperature of negative, that's below zero, negative 320 degrees Fahrenheit. That is very, very, very extremely cold. Colder than any temperature recorded here on the coldest place on Earth. Can someone tell me, what is the coldest place that we have on Earth? What do you call that place? Let's see. Yes. Colder than Alaska. Literally colder than Alaska. Amazing. Very, 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 very cold. It's gonna be. Colder than the North Pole. Antarctica. Excellent. So guys, Antarctica is the coldest place here on Earth. This stuff boils at a temperature that is about, actually over 200 degrees colder than the coldest temperature recorded on Antarctica. Coldest temperature on Antarctica was about negative 117. This stuff is a lot colder than that. And that's why I gotta make sure that I keep on all this gear, that you guys stay behind those cones, because this stuff is actually used to remove little bits of skin. It immediately gets rid of all of that because it is so, so, so cold. It can cause severe, forgot the name right now, but severe frostbite. Now, here's what I'm gonna do. We saw that it changed from a liquid into a gas, but guys, where is the gas? Can you point to me where here in this room is a gas? Right? It's all over the place, it's everywhere. But I wanna see that because again, like scientists, we don't wanna rely on things, we want to see them. So I'm going to take a little bit more of my liquid nitrogen and I'm going to pour it into this container. Now I want to collect the gas, so I'm going to use something in order to collect all of that gas. And it's probably something you've seen before. Let me grab my very special piece of equipment.
Balloon.
Just a balloon. Alright, I'm going to place that on top of my bottle. And again, like good scientists, I want you guys to make some observations. I'm going to come around to show you what's going on. So guys, what do you see is happening here to our balloon? What's going on? What do you see? Yes, she sees that the gas is filling up the balloon. And guys, where are we getting that gas from? Where's the gas coming from? Yes, the bottle, right? So this liquid right now, it is boiling and it's changing from a liquid into a gas, and it's being collected up here. But guys, how here or anything that's giving it that heat? Where are we getting the heat from to change this? What do you think? Right, just the air around us. Remember guys, this boils at -320. Is it -320 right now? No, it's a lot warmer. And because it's a lot warmer, we're using this heat energy to change the liquid into a gas, and we're collecting that right up here. Now guys, my balloon is getting pretty large, so I'm gonna move this to the side. I want you guys to notice something. I only put a little bit, this much liquid nitrogen into my container. What has more volume? Raise your hands for this little bit of liquid nitrogen in the container, or for the balloon. So, hands for the liquid nitrogen, hands for the balloon. You guys are really smart. Look at it. Definitely the balloon. The balloon, that gas in there, it takes up a lot more space than the liquid that we have in our container. Remember gases? They like to take up lots of space. So what I want to do is I want to show you guys, even though I filled up that balloon, if I had actually filled up this to the very, very top, I could fill up hundreds and hundreds and hundreds of balloons. But even though I filled that balloon, we still have a lot of that liquid nitrogen left over. Remember again, liquids don't have as much energy, thus they do not take up as much space. Okay, so we saw a liquid change into a gas. And we have a special name for this when a liquid changes into a gas. What do we call this? Yes. Evaporation. Excellent. We can say evaporation. We can also say boiling. Well, I want to do something a little bit different. I want to do the opposite of that. And to do that, I need a gas. So I have a few gas collectors back here. And I'm just going to, excuse me, grab one. And here's what I haven't told you. This container up here is filled up to the very, very top with liquid nitrogen, what I've been using. Look at the balloon. Look at the size of the container. Do you guys think that I could fit this balloon into this container that's already filled with liquid nitrogen? Raise your hand for yes. Raise your hand for no way. Oh man. Well, you know what? I'm gonna try it out. Let's see if maybe somehow this will work. So I'm gonna open this up, put that right in there. Guys, is the balloon fitting into the container? What do you think? You can say it out loud. No, it's not fitting on there. It's sitting right on top of that liquid nitrogen. Okay, well, you know what? I'm gonna try to help it. Maybe if I put the lid on top, maybe somehow that'll help. So let me see, if I have that lid on there, what do you think? Do you think it's gonna fit into the container? I see some thumbs up over here. Look at that. Perfect. Our balloon is fitting into the container. But you know what? In science, do we only do things one time? No, we do things multiple times. So I'm going to grab another balloon. Let's see if this will work out a second time. Remember, in science, we want to make sure that the first time around wasn't just a mistake. Again, this balloon is a lot larger than the container. The container already has the nitrogen. Let's find out if this is going to fit.
My group stays here.
Again, is our balloon really fitting in there? No, it's not. But we're going to try and save it. Let's try with the lid.
Good.
Maybe we can get the balloon in there. Alright, perfect. So we've got 2 balloons in there. But guys, should I maybe try a third balloon? What do you think? Yes, I see a lot of thumbs up. Excellent. So we're going to do one more last balloon. Okay, I think this one will definitely fit. Look, it's actually smaller than the other one, so let's plop that one right inside. Now, as I'm doing this, I want you guys to think, how are these balloons fitting in there? Somebody raise your hand and tell me, what's going on? How are they all fitting in there at the same time? Yes, sir. They're getting smaller. Okay, they're definitely getting smaller. What else do you think might be happening? Yes, sir. He said that it's getting so hot that it's burning the balloons, and that's how they're fitting in there. Okay. Anybody else? Any other guesses? Let me see. You saw it? You saw it go in there? Oh, cool. Alright. Well, let's find out. Let's take these balloons out. Let's see what they look like. Sweetie, do me a favor. Just move a little bit back. Thank you. Alright, so let's take these balloons out. I'm going to put a little bit more of the liquid nitrogen right in there. Let's see what they look like now that they've been in the liquid nitrogen for just some time. Alright, I'm going to take out the pink one that I just put in there. look at this, guys. It's like a pancake, very, very flat. We leave that one right there. And let's see. I'm gonna take out the white one, just like it, like a pancake. But guys, do you notice anything is happening to these balloons? What's going on? What's happening to them? What do you see? Right, they're getting bigger. They're blowing up. Perfect. I move this one a little more away. All right. Well, let's take out this last one. It was a yellow-colored balloon. Let's see if maybe we can tell what's going on. So guys, at the bottom of this balloon, does anybody see anything in there? Raise your hand if you see something moving in there. What state of matter do you see at the bottom of my balloon? Someone, you guys can say it out loud. Do you guys see a liquid? Raise your hands if you see a liquid at the very, very bottom. It's harder to see now. But you are right. If you saw a liquid down there, when we brought these balloons out, there was a liquid, and that liquid was actually liquid air. So when we put the balloons in here, it was so, so cold, and you guys can tell how cold it is. There's actually frost on this container, very much like so. And it's so cold in there that all the gas molecules, they huddled up, they got very, very close together, and they changed their state of matter from a gas into what you saw, a liquid. But did they stay like that? No. When we brought them out, what did we add to the balloons to change that liquid into a gas? Yes? We added air, and what did that have? It had space. Yes, it had heat. So we added heat from the room, and we changed that liquid back into a gas. And we have a name for this. When we change a gas into a liquid, we call that condensation. Can you guys say that with me? Condensation. Perfect. So for our final experiment, we are going to make something really cool with condensation. Now guys, for this one, we're going to have a little countdown. Now, I need your help. I need your cooperation. I need everybody, again, just like you're doing it right now, you're going to stay behind those orange cones. During my program, I've been heating up some water, and I've been boiling it. What I want to use from this is the gas that is rising up. So I'm going to pour my hot water right here. I just want to use some of the gas rising from this. And I want to change that gas into a liquid state of matter. But to do that, I need something very, very cold. What can I use up here that's very, 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 very cold? Yes, ma'am. Right, the liquid nitrogen, perfect. So I'm going to use the liquid nitrogen. Now guys, if you have ever heard of the water cycle, here on Earth we have these big bodies of water like the ocean. The sun shines down on them, and some of that water changes the state of matter into a gas. The gas rises up into the sky, and it's very, very cold at high altitudes. So just like that, let's see what happens when we have a gas and we make it very, very cold. All right, guys, now I'm going to need your help with the countdown. We're going to go 3, 2, 1, condensation. Could you guys all help me with that? Perfect. Here we go. And